Okay, so here are the answers for those 5 examples for you guys to try. If you have any questions, please be sure to write them down. That way then we can deal with them in class, okay? If we look here at, so we're going to talk about intermolecular forces. So there's 2 different types of forces. There's intramolecular forces, which are forces of attraction within molecules. For example, we have ionic or covalent bonding. Okay. We also have intermolecular forces, which are forces of attraction between molecules. Okay. These intermolecular forces are responsible, they're the weakest of all forces, and they're responsible for state, melting point, boiling point, etc. Okay? There are 3 types of intermolecular forces that we look at. One is dipole-dipole forces. So these are electrostatic forces of attraction between the dipoles of a polar molecule. So the slightly negative poles attract the slightly positive poles in the other molecules and vice versa. So we can see here that there would be these states of attraction between these particular atoms, between these particular sections of these molecules. Okay? Another type of force is hydrogen bonding. So this is a special type of dipole-dipole interaction that is very strong. Hydrogen bonding is the attraction between a hydrogen on one molecule, which is bonded to an oxygen, a fluorine, or a nitrogen, and to that of the adjacent molecule. Okay, so hydrogen bonding only occurs if we have a hydrogen molecule which is bonded to one of those and they're attracted to the adjacent molecule. Okay, so when a hydrogen is bonded to a highly electronegative element, such as those 3, the electrons are pulled far away from it. So it causes a very positive end. Okay, since hydrogen doesn't have any other electrons, its proton is basically exposed. So this proton is then able to be attracted not only to the electronegative pole, but also to the lone pairs. Okay? So we see an orientation kind of happening like this. And this is why water is so polar and it bends and this sort of thing. Okay? We also have London dispersion forces. This attractive force occurs between all molecules and is called this London dispersion force. Okay, it's the result of the electrostatic attraction of induced dipoles. So these are not dipoles within the molecule, but these are ones that are induced. So electrons within atoms and molecules are always in constant rapid motion. So for brief instances, the distribution of the electron becomes distorted, which produces a very weak dipoles. So these are not dipoles that we would notice in a molecular structure. This is something that is caused just by this rapid movement of electrons. So this temporary dipole induces a dipole in the adjacent molecule when like charges repel each other. This process disperses throughout the substance, causing flickering dipoles that attract each other. Even though this force lasts only a moment and is very weak, the overall effect of the substance is significant. Okay? London dispersion forces are affected by 2 factors. So one is the size of the atoms. So more electrons means a higher probability of creating temporary dipoles. Also, the shape of the molecule. So the more contact between molecules, the higher the force of attraction. So we're going to look quickly at the scale of forces in the next video.